Today we're going to get into inverse functions. Inverse functions are a little bit strange and scary, so you need to face your fears on the National Face Your Fears Day. And inverse functions are where you switch the range and domain, and we're going to do some calculator work up front, which may be a little bit unpredictable today. And we're going to look at making sure I'm in the right mode. I want to be in degree mode. Incidentally, tomorrow is going to be a big day in here again, and it's going to be talking about radians. Radians are a different way to measure an angle like degrees. And that's going to carry forward in trig and in actually calculus class. So most trig functions are using radians because it's more natural. And when you do certain calculus maneuvers on it, it will make sense to do it in radians, not degrees. So that will be an important lesson tomorrow. Well, let's go ahead and go to inverse functions. And what I want to do is just play around with some numbers here. So I want to do the inverse sine of, let's say, a number, which is just 0.5. And when I do this, that's going to give me 30 degrees. Why? Sine 30 equals 0.5. We know that from the table. However, if I do the same thing and stick a negative 0.5 in instead of a positive 0.5, I'm actually thinking about what is the angle such that the sine of the angle is equal to negative 0.5. Notice what happens here. I get a negative 30. If I think about the reference angle, where the sine of the reference angle equals 0.5, my reference angle actually is a positive 30. Reference angles are always positive. Reference angles are going to be the angle formed by the terminal side and the x-axis, either positive or negative. So far, if I'm looking at using the inverse function on my calculator, it looks like it's giving me my reference angle, except it could be negative in some cases. Let's go ahead and use tangent. Second tangent, which is the inverse tangent of, let's say, 2 is equal to 63.43 degrees. That is the reference angle. So the tangent of 63.43 is equal to approximately 2. Let's go ahead and insert a negative again. And you're going to see that you have a negative 63. Somewhat predictable. That could be my reference angle if I know what the number is, which would be negative 2. The only other one that we have is cosine. And so I want to do the same exact thing with cosine, and this is where it may get a little bit scary here. You have to face those fears. Let's say 0.5. Cosine of what angle is equal to 0.5? You should be thinking cosine of 60 degrees equals 0.5. And now when I insert the negative 0.5, you would predict, based on the other inverse trig functions, that you're going to end up with a negative 60 here. However, it gives you 120. And there's a reason that it gives you 120 and not negative 60, and that reason is that trig functions are defined over a certain interval, and that interval is based on the fact that it's actually a function. Each x has to have exactly one y. We're going to get into that in the graphing unit, which is chapter 4, but right now just understand that when you do inverse functions, it doesn't kick out the reference angle every time. It may kick out the reference angle, but other times it will not. But what it will give you is a clue on what the reference angle is. This clue is drawing 120 degrees and knowing that there's 60 more degrees to get to the x-axis, and now you know what that reference angle is. So we're using this number as a clue to get to really what my reference angle is. Remember yesterday we found out that a trig function of a reference angle is equal to a plus or minus the trig function of an angle. So because it's plus or minus, we have to adjust a little bit for the reference angles. All right, we're going to go ahead and look at more with reference angles, and we're going to get into just solely inverse functions. These sections are easy if they're by themselves. The problem is when you start combining sections, things can get confused, and that's why we have a big rock sheet, and you should be putting on notes as you go along and studying off of it. The first thing we're going to look at is that you remember that the sine of theta is equal to some number, as well as the sine inverse of a number is equal to your theta. You're switching the domain and the range around here and adding the inverse. So what we have is find theta if sine theta is equal to a negative 0.5592 and theta is in the third quadrant. And we also know that theta is between 0 and 360 only. That's the question we're working with. The goal is to do this. Find the reference angle. Once you get the reference angle, you figure out what the angle is based on what quadrants it's in. So the very first thing we're doing in this problem is find the reference angle, then apply it in a drawing. Well, how do I find the reference angle? I have to go to my calculator to figure out what my clue is for my reference angle. So I'm going to go ahead and figure out the inverse sine of negative 0.5592. And you're going to see that it's negative 34.00. Now that means that your reference angle is actually a positive 34.00. There are two ways to do this. One way is you can say, all right, based on my work there, I know that my reference angle is going to be approximately positive 34.00 degrees. You're going to adjust this angle so it's your reference angle. The other way to do it, and you just need to pick one way, the other way to do it is to say, you know what, instead of having a negative number here, I'm always going to make that a positive number. And if you always make the number a positive number, the calculator will always give you the reference angle. So if you take the absolute value of what's in parentheses there, it'll always give you a reference angle. For example, if I go back and say, you know what, I'm going to change that just so it gives me my reference angle for the time being, I know that the reference angle is going to be this. Notice it would work for the cosine inverse as well. If I made this an absolute value of negative 0.5 or 0.5, it would give you 60 degrees, and that would be your reference angle that you could use and find whatever you want. So either use a positive number always, or adjust the number at the end to find your reference angle. Pick a way that you feel comfortable with. Once you know what the reference angle is, then it's a matter of drawing it, and it says it's in the third quadrant, so you're just going to be showing that this 34 is in the third quadrant. And now you can see that this is 180 degrees, and you know that's 34 degrees, so then your theta is going to be the sum of the two, because you're talking about all the way around here. And therefore, you're looking at theta is equal to 180 plus 34.00. And so it's going to be 214.00 degrees. Now, that's one type of question. The other type of question you may have is, what about all the angles? Not just the one in the third quadrant, but all of the angles that continue to end up in the third quadrant, not just the first one. How do you write that one? Well, that answer is going to be theta is approximately 214.00. That's that answer. And then what I'm going to know is that it's going to keep going around and hitting that angle in both directions, positive and negative. So I'm either adding or subtracting 360 to that. So how do I write that down? Plus 360K. And what does K represent? K actually represents integer values, which are 0 plus or minus 1 plus or minus 2 plus or minus 3. And you would see that that's going to be multiplied by a multiple of 360. That's going to be adding a multiple of 360 to the 240. This isn't that clear, so I'll rewrite it. Tangent of theta equals negative 0.8541. And we're talking about your fourth quadrant is where the angle is. First thing I want to do is figure out the reference angle. We're going to see if I do it this way, I'm going to know that the reference angle is going to be approximately 40.50. Well, that's fine with the reference angle. Notice I'm not writing the inverse tangent is equal to the reference angle. It doesn't. It can be the negative of a reference angle. But I'm careful with my notation here. I'm not just, you can turn it around and say tangent inverse of negative 0.8541 is approximately equal to negative 40.50. But I'm not saying it's a reference angle, I'm not saying it's my theta, I'm just saying it's a number. It's a clue to get what you want, which is the reference angle. Again, once you have that, you draw in the fourth quadrant, you draw in the reference angle, that becomes 40.50. Always positive again. And now the question is, let's see, this whole thing is 360 around. I really want to know what this angle is. So I have the whole, which is 360. I have a part, which is 40.50. And now I know what the other part is. So theta is going to be approximately 360 minus 40.50. I'm going to leave the for all angles on the tangent because it's a little bit different, and we'll wait on that one for later and get back to this. One more type of question, last question. Find theta if secant theta is equal to 3.8637, and we're talking about quadrant 4. same idea. We want to go through, find the reference angle, and then draw it in. So again, with secant theta, you put down in terms of friendlies, which is 1 over cosine theta. It looks scary, that secant theta. We change it to something more comfortable with to face our fears, and then we can adjust it at that point. I can do the reciprocal of both sides. Cosine theta equals 1 over 3.8637. At this point, we use the inverse cosine. That's going to equal approximately something. It could be my reference angle. 386. And when I do that on the calculator, I end up with 74.9975 approximately. That means my reference angle is going to be approximately 75 degrees. I'm going to draw it in the 4th quadrant, and I'm always using these drawings to help me out. It doesn't take any time, and it just helps clarify. 360, again, my question is, what is my theta? So I'm going to take 360 minus 75, and so my theta is going to be approximately 285.00 degrees. Keep organized in the class. Every single section is going to add another layer and another layer, and we're going to keep adding layers to the basics. And so the way to keep organized is through the big rock sheet. The key to your success and facing your fears in this class is to keep an organized big rock sheet.